Hello, and welcome to Solutions for Scaling Massive Global Games in the Cloud. I'm Rob Martin, Chief Architect for Gaming at Google Cloud.
And I'm Sebastian Wigan, a planet-scale systems architect on Rob's team.
And today, we're going to be talking a lot about global games. First, we're going to define what we mean by a global game. Next, we're going to define all of the components that are used to power a global game in the cloud. Then we're going to do a demo. And finally, we'll close out with some thoughts on a toolkit for building your own global game in the cloud. So let's start by talking about global games. Gaming is the world's most popular form of entertainment, with 2.7 billion players globally. And that number is expected to increase by another 500 million by 2023. Let's talk about an example of a truly global game. Apex Legends is a great example of a truly global game. Apex Legends launched exclusively on GCP with our partner Multiplay. Within the first 8 hours after launch, over 1 million players had played the game. Within the first 3 days, that number 10x to 10 million players. And by the end of the first month, over 50 million players had joined the fun in Apex Legends. So let's talk about concurrency and scaling. A CCU is defined as one concurrent player. Peak CCU is the maximum number of players during the day that will be playing your game all at one time. You can see many points of peak CCU illustrated in the diagrams to the right. As players join your game, you'll need to scale up infrastructure to meet that demand. So in some sense, as more CCUs join your game, you'll need to scale up more CPUs in the cloud to power the multiplayer experiences. Let's take a look at a few different examples of peak CCUs. So the first example is a premium launch, where the game is launched perhaps at retail. There's a very large peak CCU spike on the first day, and then you settle into a predictable pattern in the following days. Or in the second example, you might have a mobile launch where you have a limited beta, and then over time, user acquisition opens up to add more and more concurrent players. What we're seeing more and more of today with today's free-to-play games like Apex Legends that incorporate content drops, seasons, and live events is you're seeing peaks happening throughout the game's life cycle. So in today's world, it's very important to be able to scale to these unpredictable demand peaks that are generated by these new types of content releases. And so we've talked about concurrency and scaling. Now let's talk about geography. So using an example game with 1 million concurrent players, those players are going to be distributed all around the earth. Using this example of a typical AAA PC console game, we would expect about 40% of those concurrent players to be located in North America. We'd see about 30% of those players in Europe, about 10% in South America, and then the remaining 20% of players distributed across the Middle East and Asia. Now, because latency matters in gaming, you're going to need to deploy your compute resources all around the earth to get them as close as possible to your players. So as Seb and I prepared for this demo, we thought to ourselves, would it be possible to scale up all of the compute infrastructure required to run a global game for 1 million concurrent players within the space of this 25-minute demo? What do you think, Seb?
With the right tools, anything is possible.
All right, Rob, let's dive in. I've created these clusters already, and I've installed Agones onto each of them. Right now, these are essentially empty clusters, running only a few nodes each. I've got one cluster in the US, another in the Netherlands, and a third in Japan. Because our Cloud Console aggregates information across clusters, I can see that I don't have anything running in these clusters yet, besides the pods needed to run Agones itself. I've coded up a game server in Go, which simulates a Battle Royale-style game. It records the events which typically take place into BigQuery, our data warehouse. It also creates player information such as match rankings and writes those into Spanner, our horizontally scalable relational database. To deploy this server worldwide, we define it using an Agones game server fleet spec combined with a Google Cloud Game Server's deployment. The fleet specification looks just like any other Kubernetes resource. Agones provides an abstraction layer on top of Kubernetes to understand the concept of a game server or collection of game servers called a fleet. It does this because game servers aren't your typical stateless workload. You don't want your game to get killed in the middle of a match and scheduled on another node, for example. Likewise, Kubernetes needs to know more information about the state that the game server is in, such as total player count, to handle functions like scaling properly. Agones takes care of things like this for us so that we don't have to. Let's take a look at our current fleets on each of the GKE clusters. As you can see, we don't have any fleets deployed. Let's go ahead and create a ton of game servers. To do this, I'm going to ask GCGS to apply a new rollout using the configs I've specified. What it'll do is connect to every GKE cluster in each of the realms and create the Agones fleets based upon our fleet spec. In short, we'll go from no pods to thousands across multiple clusters in multiple continents. Here, you can see the number of servers that we want, the number which we are booting up, and the number which are ready. The allocated column would update once players start connecting to them. Rob, you asked about scaling up enough resources for 1 million concurrent players. Deploying thousands of these servers across 10,000 CPU-optimized cores ought to do the trick. Let's check those GKE clusters. Remember, we only had one node in each zone. Let's see what it's up to now that the cluster autoscaler has seen our request spike. This is great. The cluster autoscaler has already begun adding additional nodes to these clusters based upon the resources that we've requested. Okay, more and more game servers are coming up. Agones and GKE are working together to spin up additional virtual machines to handle this load. This will take just a couple of minutes to scale up. Let's check back in on these later. Back to you, Rob.
Thanks, Seb. It'll be interesting to watch that scale up. And while that's happening, let's talk a little bit about the components that are required to power a global game. So first, you need a global network to connect with your players. Next, you need high-performance compute to run your simulations and your multiplayer matches. Then you need a global database instance to track player progress throughout the game. You need to monetize your game, so you'll need planet-scale analytics that can absorb all the events you're going to be posting. And then finally, you need a fleet orchestrator to bring it all together and to scale this infrastructure up as players join your game and to scale it down as players move on to other activities. Let's take a look at each one of these components in more detail. Let's start with our global network. The first thing that you'll notice on this diagram is the 24 regions distributed around the globe. These are represented as colored circles and are the geographies where you can run your compute resources to power your matches. The next thing you'll notice is our 144 edge points of presence that are located as close as possible to your players. Now, the unique and differentiated thing on this diagram is the fiber optic network that ties our edge points of presence and all of our regions together. Only Google Cloud offers a global private fiber optic network out of the box. Next, let's talk about compute, which you'll need to power your multiplayer matches. So we know that there are many different types of games, from a casual mobile title that you play on your phone with friends, to a powerful and high-fidelity multiplayer battle royale match that you play on your PC or console. At Google Cloud, we've created a spectrum of compute that you can tailor to the specific needs of your game. So for that casual title, you could run on our cost-optimized VMs. And for that high-fidelity battle royale title, you can run it on our compute-optimized VMs, which run at high clock speed and we built specifically to run demanding workloads like games. Next, let's talk about a scalable database. As players progress through your game, you'll need a way to capture updates like rankings and updates to inventory. The way that a database for a global game is typically built is by utilizing a commodity database like MySQL and running tens or even hundreds of instances to power a global game. This technique is not globally scalable, and from an ops perspective is not awesome. At Google, we offer an alternative approach with Spanner, a horizontally scalable relational database. We offer the capability to run a single instance that can serve all of your players globally without shards. Now that's awesome. So we've talked about a lot of different infrastructure components that'll be required to power your global game. It's going to be important that you can effectively monetize, particularly in today's free-to-play world. BigQuery offers a globally scalable data warehouse that can scale from launch to the world's biggest games with zero ops for your team. Candy Crush is probably the best example of scaling running on BigQuery. Candy Crush ingests over 70 billion events per day seamlessly, and Google manages all the ops. So to tie it all together, you'll need to scale these resources up and down throughout the day as players join the game and move on to other activities. To manage the scaling of all of these resources deployed globally, we built Google Cloud Game Servers, a global control plane for running your game. Google Cloud Game Servers is built on top of open source technology, including Agones and Kubernetes, which allows you to run your infrastructure components wherever you need them, in GCP, on other clouds, or on bare metal. Let's take a closer look. In this diagram, we're showing the Game Servers API, which is your global API and control plane for managing your game. On the left, we have one Kubernetes cluster that's running in Google Cloud Platform on GKE. On the right hand of the diagram, we have another Kubernetes cluster that's running on-premise on bare metal. Both clusters are being centrally managed by Google Cloud Game Servers, and all of the operational events and log events are being captured centrally. Agones and GCGS offer a new cloud-native way to build your game. Let's talk about the roadmap for building your game with this new technology. First, you containerize your game and implement the open source Agones SDK. Next, you register each of your clusters with the Game Services API control plane. Then you begin organizing your clusters into groups by geography that we call realms. Next, you define configs for things like autoscaling policies. And finally, you test and roll out your game server binary to your global fleet of game servers running on Kubernetes. So let's check in on our scaling. Seb, how do you think things are looking?
Pretty good from here. Let's take a look.
Okay, Rob, let's take a look and see how our servers are coming along. So far, we've got 4,200 servers running in the US, a little over 3,300 running in the EU, and 500 running in Japan. This is truly a global fleet, more than enough to support 1 million concurrent players, as each server can handle at least 150 players. It took under 8 minutes to scale up all the compute needed for a massive deployment all around the world. This really demonstrates just how easy and powerful managed Agones really is. Now, let's take a look at the database. Here we can see the number of nodes we're currently using, along with the CPU utilization and number of concurrent requests. Wow, that's a lot of requests, and this number should keep rising as more and more game servers come online. We're running about 80,000 queries per second, which is about what you would see for a very large global game. Should we need to handle more, rather than deal with database sharding, we simply increase the node count in Spanner and it handles the rest. You gotta love the separation of compute and storage. Now, let's check BigQuery, our gaming data warehouse where we've been ingesting massive quantities of telemetry events since we started our fleet. So far, this table is just about 100 gigabytes with over 800 million rows. Excellent, but let's figure out the number of events processed per second. Even though there are thousands of game servers inserting data right now, let's ask BigQuery to take the number of events between the last 2 minutes and 1 minute and then divide by 60. What I love about this is, we can keep inserting more and more data and let our scalable databases handle the rest. When your cloud can scale to ingest data like this, your team can focus more on creating really great games and less on managing your infrastructure. Wow, over 800,000 rows per second. Not bad. So Rob, in less than 10 minutes, we scaled up close to 10,000 cores of compute on 3 continents, wrote over 80,000 inserts per second to a global database instance, and ingested over 800 million rows to our data warehouse. Talk about scalability.
Wow, those are some impressive numbers, Seb. We were able to scale all of the infrastructure required for 1 million concurrent players in about 10 minutes. To recap, let's take a look at each component in this toolbox for building massive global games on Google Cloud. Our premium network offers a global fiber optic network that extends your reach to wherever your players are around the globe. Compute-optimized VMs offer the high clock speeds required for today's most demanding games. Spanner provides a global database instance for your game with no sharding. BigQuery is a planet-scale data warehouse that can ingest millions or billions of events each day for your game. And finally, Google Cloud Game Servers, the fleet orchestrator that can scale these resources up and down seamlessly during the day as your players need them. To learn more, join us on the web. And we'd like to thank you for joining us today. So Seb, that was a pretty cool demo. We were able to scale up 1 million concurrent player fleet in about 10 minutes. So for our viewers, what would it take to scale up a fleet for 10 million concurrent players?
Well, because the infrastructure and technology are sort of taken care of for you, the only thing that I could think of would be more quota.